Hey guys, today we're going to be going over the scale drawings practice test. In this video, we're going to go through solving problems involving scale drawings, computing actual lengths, and reproducing scale drawings at a different scale. Looking at question 1, since it says select all of the true statements, that is usually an indicator that there is more than one correct answer, so I need to make sure that I go through each of these and double check them. A says segment BC is half the length of EF. So when I look here, I see that this is BC, and if I'm going to try to match anything, I need it to be a corresponding part. And EF is down here at the bottom. So A is not even something that we can solve since they are not corresponding parts. So A is not the correct answer. B says segment CD is half the length of segment GH. Well, I know that GH is 8, but I don't know what CD is. But I know that half of it would mean that it should be 4. To be able to check this, I might need to use some other corresponding lengths to check, are they half? So the only other lengths that I see that both shapes have is this length right here, 10 and 5. And I see that 10 is half of 5. I can divide 10 by 2. And I get 5. So I want to see is 8 divided by 2 would also give us 4. So B is a correct answer. C says the measure of angle ADC is equal to the measure of angle EHG. So I highlighted those in red, ADC, EHG. So first of all, they are corresponding angles. And one thing that we learned in this unit is that angles in scale drawings are always going to be congruent or equal. So C is also a correct answer. D says the length of segment AB is 3 units. So I need to use the corresponding part on the bigger figure to see if I were to double that, since we already did determine that we are multiplying by a half or dividing by 2. Remember, those are the same things. So I need to see if I go opposite, if I multiply by 2, 3 times 2 is 6. So D is also a correct answer. The last one we need to check is E, and it says the area of ABCD is half the area of EFGA. Now, even without having all of the numbers to be able to do the math here, because this is a weird shape, we don't have a formula for area of whatever the shape is. It's not a rectangle, it's not a triangle. I could divide it and try to figure out the areas, but I know that to find the area of a scale drawing, you take the scale drawing area and you multiply it by the scale factor squared. And so I know that if I'm doing area times the scale factor squared, square factor squared is never going to be half. So I know that answer E also does not make sense. Question 2 says rectangle A measures 8 inches by 2 inches. Rectangle B is a scaled copy of rectangle A. Select all the measurement pairs that could be the dimensions of rectangle B. Here I know again that since it says select all, that there is probably more than one correct answer, so I need to make sure that I double check all of these. So I know that for it to be a scale drawing, I need to multiply by the same number every time. So with the first one, since I know my multiplication facts, I could think 8 times what gives me 40, and I know that 8 times 5 is 40. And then I would just want to double check, does that work for 2 as well? And 2 times 5 is also 10. So A is a correct answer. But I'm going to have to use a different strategy for B because I'm not sure what I can multiply 8 by to get to 10. So I'm going to need to kind of do the opposite of that, and I can do 10 divided by 8, and then 2.5 divided by 2. And I want to see what answers I get when I do that. So when I use my calculator to do 10 divided by 8, I get 1.25. And then when I do 2.5 divided by 2, I also get 1.25. So I know that they use the same number to multiply, so the scale factor is 1.25, and B is also a correct answer. I'm going to have to use that same strategy on C, D, and E because at this point, my multiplication facts aren't going to give me these numbers. So I'm going to need to take my new drawing and have 9 inches, and I want to see if that will give me the same thing when I do 9 divided by 8 versus 3 divided by 2. So remember, the 8 and the 2 are just coming from the original problem, and the 9 and 3 are coming from the answer choices. So when I do 9 divided by 8 in my calculator, I get 1.125, and when I do 3 divided by 2, I get 1.5. Since these are not the same answer, C is not an answer choice. For D, I'm going to do 7 divided by 8 Again, that 8 is just coming from the original problem, and 1 divided by 2. Here, I don't even have to do math to know that this isn't going to work out, because I know that 1 divided by 2 is 0.5, and I know that 7 divided by 8 is not 0.5. It's bigger. It's bigger than a half. But when I check this, 7 divided by 8 is 0.875. So since I didn't get the same number, I know that D is not an answer. The last one to check is E. So I'm going to take the new measurement of 6.4 and divide it by my original 8. And then I'm going to do the same thing with the 1.6 new measurement and divide by the original 2. The times that I do that, I get 0.8. So I know that since I got the same answer, that this scale factor would be a 0.8 scale factor. And so E is a correct answer. Question 3 says a scale drawing of a rectangular parking lot is 6 inches long and 5 inches wide. The actual parking lot is 240 feet long. What is the area of the actual parking lot in square feet? There are a couple ways we can go about solving this question. I can find new lengths and widths and then find the area of that, but to be able to do that, I need a scale factor, and right now I don't have the scale factor. So we would need to set up a proportion. Or if we know how to get from 6 inches to 240 feet, we could have that as our scale factor. So I know that for scale factor, we've got to multiply by the scale factor. And so here I would need to think 6 times what is 240. And I may not know that, but we can always work backwards. And the inverse of multiplying is dividing. So we can do 240 divided by 6 and see that our scale factor is 40. With that information, I can actually use our area formula for scale drawing, which is the area times the scale factor. In this problem, the area of this drawing would be 6 by 5. I would use that area of 30 and multiply it by the scale factor squared, which we just determined our scale factor is 40. So in my calculator, I would do 30 times 40 times 40, which gives me the answer of A, 48,000. The other thing that I can do is set up a proportion to solve for how wide my rail park is. So I set this up knowing that 6 inches long goes with 240 feet long, so I matched long to long. And then I had a remaining number in my problem of 5 inches, so I matched that on the top with inches. To solve a proportion, we're going to cross multiply the two numbers across from each other. And you get 1,200 here, and then you divide by the number that is left, so 6. And this tells you that the new width is 200. So even though this is an answer choice, that does not mean we are done, because all I have found is that my rail park is going to be 240 long and 200 wide. So now I have to find the area of that. And so to find the area of a rectangle, we just do length times width, or base times height. In this case, we're going to have 240 times. And so we can see that this method gets us the same answer of 48,000. Question 4 says, here's a polygon. Draw a scaled copy of the polygon using a scale factor of 1/3. So I know that this means my picture is going to get smaller because I have a scale factor less than 1. First thing I did was count all of the side lengths of my original picture here, and I color coded them. So here I can see that really I only have 3 different numbers that I need to multiply by 1/3. So you can see here that I multiplied each of my original side lengths by my scale factor of 1/3. And I got my new measurements. And so now I just need to draw this with each side corresponding to the correct measurement number. So you can see up here that I made the blue sides 3, the red sides 2, and the green sides 1. On question 5, we're going to set up a proportion, and we're going to start by using our scale. Our scale is always going to be the first fraction in our proportion. But my scale is 8 centimeters over 5 kilometers. Now in part A, it tells me I need to figure out how many centimeters is an actual distance of 8 kilometers. So when I match the 8, I'm looking for kilometers, which is in my denominator. So I'm going to put 8 kilometers in the denominator, meaning I'm solving for however many centimeters. My first step to solving a proportion is to cross multiply diagonally. 8 times 8 here is 64. And then we need to divide by the number that's remaining. 64 divided by 5 gives me a final answer of 12.8. Since I know that I was solving for centimeters, I need to make sure that I tell that this is 12.8 centimeters. Part B says, what is the actual number of kilometers that is represented by 5 centimeters on the map? So again, we always start with our scale as the first fraction, 8 centimeters over 5 kilometers, but this time I have 5 centimeters, so I'm going to match centimeters to centimeters. We're going to solve this proportion the same way by starting by 5 times 5, 25, and then we're going to divide by the number that's remaining, in this case 8. And 25 divided by 8 is going to give me a final answer of 3.125 kilometers. I know this is kilometers because we were solving for something in the denominator, and since the denominator had kilometers, we're going to keep kilometers. For question 6, we have two different maps of California. One has a scale using centimeters to kilometers, and the second one also has centimeters to kilometers. There's going to be a couple steps to this problem. First, I need to use the original scale in the beginning, which is 1 centimeter to 20 kilometers. And then I know that the distance on the map is 15 centimeters, so I need to see how many kilometers that is in real life. Solve this proportion the exact same way. Cross multiply what is diagonal, 20 times 15. And that gets us 300. Always remember to divide by what's left. In this case, 300 divided by 1 is still 300. I couldn't have just moved on to the second scale yet because they didn't give me enough information. But now that I know in real life that from Fresno to San Francisco is 300 kilometers, I have a third piece of information now that I can use for the second map. So I'm going to use that information of 300 kilometers and the scale that they give me in the second map. So I started this by setting up using my scale in the second map, 1 centimeter over 100 kilometers. That first fraction is always your scale. And then we just solved that in real life. The distance is 300 kilometers, so I matched that with kilometers. Now we can solve this by cross multiplying. 1 times 300. Always divide by the number that's left, so 300 divided by 100 gives me 3 centimeters. So in this answer, it says, what is the distance from Fresno to San Francisco? In the second map, explain your reasoning. The distance from Fresno to San Francisco is 3 centimeters. I know this because I had to find the real distance using the first map scale and the information they gave me to find out that Fresno to San Francisco is 300 kilometers. After I knew the real distance, I could use the real distance and the scale of the second map to see how many centimeters it would be on their map. Question 7, you were supposed to skip. That is the question that we're going to do on our constructed response for this unit. The last page is your study guide. So here it says the photo below is being enlarged to form a 24 by 30 inch print. What is the scale factor being used to enlarge it? So that scale factor is the number we multiply by, so I need to think how I can get from this side being 24 to, from 4 to 24, and from this side being 5 to 30. And I want to multiply by the same number. I know that 4 times 6 is 24, and then I can double check that, and 5 times 6 is also 30. So the scale factor is 6. On 14, Shelby drew a map of the Appalachian Trail. The scale was 5 centimeters, represents 400 kilometers. The map shows the Appalachian Trail to be 43.75 centimeters. What is the actual length of the Appalachian Trail? Started as we always do with a proportion, my scale being my first fraction. It said the scale is 5 centimeters, represents 400 kilometers. Next, they tell me 43.75 centimeters, so I'm going to match that in the numerator where I already have centimeters. To solve this proportion, we're going to cross multiply 400 times 43.75. After cross multiplying, I get 17,500, and we always divide by the number we've not used yet, in this case 5. So 17,500 divided by 5 gives me a final answer of 3,500. Question 15 is asking about the perimeter. I know that perimeter is distance around a figure. So first I'm going to go ahead and start by getting my original perimeter, which is 29 and 21. Perimeter is 50. Now I know that my scale is 150%. We didn't use a whole lot of percent here, but I know how to change a percent to a fraction by moving my decimal 2 places. So 150% is the same as having a scale factor of 1.5. Since this is perimeter, I don't need to multiply by the scale factor squared like I do for area. Since it's one-dimensional, we're just going to multiply by one dimension of the scale factor, so we can just do 50 times 1.5. This gets me a final answer of 75 centimeters. You absolutely could go ahead and find your new side lengths by also multiplying your side lengths by 1.5, and then you would have 3 new side lengths to add together for the perimeter. For the next problem, it tells me that we are reducing by a scale factor of 2/3, so I know it's getting smaller, and it wants to know how many square inches will the map take up. I know that to find the area of a scale drawing, I can take my original area and multiply by the scale factor squared. My original area here, 15 times 21, is 315. Then I can use my calculator to do 315 times the scale factor squared times 2/3 squared. When I do this, I get an answer of 140 inches squared. Question 17 tells me the figures below are similar, so I need to figure out the length of x. To do this, I need to use 2 corresponding lengths that I do know. I like 4 and 10. So I can start by setting up a proportion with those in the same fraction. Now I need the corresponding side to x, which is 8. Since 8 is in the same problem as 4, I'm going to match that on the numerator with 4. And then I'm solving for what matches 10 in the bottom. Same way we've solved every other proportion. Cross multiply, 10 times 8 is 80. Then divide by the number that's left, which is 4, and that gives you a final answer of 20 inches. For the last question, it wants the perimeter, so I know I need to figure out what the other two side lengths are. To be able to figure out the other side lengths, I need the scale, and they haven't told us what the scale factor is. But I do have two corresponding lengths that I know, 15 and 6. I don't know any multiplication facts where I can do 15 times something equals 6, or even working backwards, I'm not sure. So I know that it's going to be a decimal because it's getting smaller, so it's going to be a number less than 1. To do this, I'm going to take my new drawing, which is 6, and divide it by the original, which is 15, and this is going to get me a scale factor of 0.4. I can always double check this by doing 15 times 0.4, and it does give me 6. I do this for all of the other side lengths as well. 20 times 0.4 is 8, and 25 times 0.4 is 10. Now that I have all three side lengths, I can add them together to find the perimeter. 10 plus 8 plus 6 will give me a perimeter of 24 centimeters. In this video, we reviewed the scale drawings, practice test, and study guide. At the end of this video, we were able to solve problems involving scale drawings, we were able to compute actual lengths, and we were able to reproduce a scale drawing at a different scale. Remember, if you didn't get some of these questions right, make sure you go back and watch how they were solved so that you can double check that you know how to solve them now. Good luck on your test. Bye, guys.